Hello everyone. Now we are going to talk about one of the most fascinating shortcuts in AI, synthetic data. The formal definition of synthetic data is information that is artificially generated by computer algorithms rather than being collected from real world events or people. In simple words, it's made up data that looks and acts just like the real thing. Think of it like a flight simulator. A pilot doesn't start their first day in a real Boeing 747 with 300 passengers. They practice in a computer generated cockpit that mimics a real plane. Synthetic data does the same for AI. It gives the model a safe environment to learn patterns without needing to touch real sensitive info. I have seen companies save months of time just by inventing the data they needed instead of waiting to collect it. So now that we've mastered the idea that we can actually create our own data, you might be wondering why we'd go through the trouble. Well, that brings us right into our next step, which is the major benefits of using it. In the governance world, the benefits of synthetic data include the enhancement of data privacy by eliminating personal identifiers and the acceleration of the development lifecycle. In simple words, it's safe and fast. Since the data is generated by a math formula and doesn't belong to a real person, there is no Mary from Ohio to worry about. So you aren't breaking any privacy laws. Plus, if you need a million records by tomorrow morning, a computer can churn those out much faster than a marketing team can find real customers. I once worked with a bank that couldn't let its developers look at real credit card numbers for safety reasons. By using synthetic data, the developers could build the AI in a sandbox without ever seeing a single real bank account. Stay with me here, because while speed and privacy are great, synthetic data has another superpower. It can fix missing pieces of the world, which leads us to its role in addressing data scarcity. The formal definition of addressing data scarcity through synthesis is the use of algorithmic generation to create datasets for rare events or underrepresented groups where real-world data is insufficient. In simple words, it's filling in the gaps. Sometimes, reality just doesn't give you enough examples. If you are training an AI to spot a very rare engine failure that only happens once every 10 years, you can't wait 100 years to get enough data. You use a computer to simulate that failure 1,000 times so the AI knows what to look for. It's like a movie director using CGI to create 1,000 soldiers for a battle scene because they only hired 10 actors. Let's break this down together. Once we realize we can create whatever we need, we have to face the big gotcha. If the computer makes it up, is it actually true? This brings us to the risk of model collapse. Model collapse is formally defined as a degenerative process where an AI model trained on synthetic data begins to lose its ability to represent the reality of the original distribution, eventually leading to a loss of diversity and accuracy. In simple words, it's the photocopy of a photocopy problem. You know what happens if you take a photo, print it, scan that print, and print it again? Eventually the picture becomes a blurry mess. If an AI learns only from fake data created by another AI, it starts to forget what the real world actually looks like. It becomes an echo chamber. I once saw a chatbot that started talking in circles because it was trained on its own previous conversations instead of real human speech. So, now that we've mastered the danger of things getting blurry, we have to look at another hidden trap: the fidelity versus privacy trade-off. The fidelity-privacy trade-off is the formal principle stating that as synthetic data becomes more accurate and realistic, the high fidelity, the risk of leaking information about the original real-world data it was based on increases. In simple words, it's the too realistic problem. If your synthetic data is too good, it might accidentally recreate a real person's profile by sheer mathematical coincidence. It's like a sketch artist drawing a random face that ends up looking exactly like your neighbor. If it's too close to reality, you've lost the privacy benefit. If it's too fake, the AI won't learn anything useful. Finding that sweet spot in the middle is where the real work happens. Now, even if you find that sweet spot, you still have to prove to the regulators that your made-up data is actually good enough to use. Which brings us to our final point: validation and utility testing. Finally, we have utility testing, which is formally defined as the quantitative evaluation of how well a synthetic dataset performs in a specific task compared to the original real-world dataset. In simple words, it's the taste test. Before you trust the synthetic data, you run a small test. You train one AI on real data and another on your synthetic data. If they both come to the same conclusion, you've got a winner. If the synthetic AI starts making wild, wrong guesses, you know your fake data isn't ready for prime time. You've probably seen this at the office when you test a dummy version of a website before it goes live.